Hello dear, welcome back. So you have started watching videos on subcomputing and we are continuing our discussion on fuzzy logic. Before starting, there's a message. You see, I'm coming from outside and I'm wearing two masks. So as you know, the country is passing through a very critical phase of COVID-19 situation. Many people are suffering. Many deaths are happening. Okay, so please be careful. Wherever you go, you wear mask, two masks, okay? And till you get your vaccine, this is your vaccine. Please take care. Okay. Now let us discuss a very important topic: fuzzy inference system design. Okay. So let me. So you see, this is called fuzzy logic expert system cell. Okay. What is a cell? Cell is just like analogous to, it's an expert system, first of all. I believe you have some fundamental knowledge about what expert system is. If not, then please brush up. And I will also try to show you with an example what is a typical expert system. Okay. So this is called fuzzy expert system. So I am using fuzzy expert system cell of MATLAB since we have access. But those who do not have access to MATLAB, there are also open source framework, expert system cell, which you can use. Okay, for example, you could Octave, you can try. Okay, so here you see what is the expert system cell? Is just analogous to a newly built house. For example, you have built a house and it is completely empty. So you are putting your furniture, your other equipments, and all kind of daily utilities products as per your desire in the house, the way you look, you want your house to look. Similar is the situation. This is an expert system cell without having any knowledge in it. I will use it to solve some of my problem which I define. Okay, so stay tuned. It is very interesting to demonstrate how a fuzzy inference system can be designed. I'm going to take an example. That is a problem, right? The problem is, suppose in your birthday celebration with your friends, you have gone to a restaurant, okay, which is of course forbidden right now. It is May 2021, and you can see that all lockdown and everything is here. But suppose it's a normal situation, and you went to a restaurant with your friends, and you are celebrating your birthday party. So you spend some money, and at the end, you are thinking of how much tips you should give to the waiter who served you. Okay, and that should be very logically given. Okay, so this is a very nonlinear, complex problem because there is no way you can mathematically model that how much I am spending. Well, there is a thumbs rule. You can give some money, but we are taking a fun example and trying to show you what are the fuzziness here and how a fuzzy expert system can help you in solving a tipping problem logically. Okay, so first of all, before solving any problem, you'll have to understand the problem, right? So here is the problem, right? Tipping problem. So what are the parameters involved here, and based on which your tipping will depend? Definitely quality of food. Say if the food quality is very high, and if the service is also very good, then of course one can generously pay tips to the waiter, so that waiter will be also happy, right? So what are the inputs, outputs? I will have to write it in the cell in terms of input output. The cell means it will do many underneath job for me, My job is only to design the expert system, okay, with all its complexity, which we have studied so far in my earlier lectures, okay. And as you know, there are two approaches of solving fuzzy inference system. One is based on Mamdani approach, another is based on Sugano approach. And in Sugano approach, the membership functions are singleton membership functions. But in case of Mamdani, they are usual membership function, since more general membership function, not singleton. Okay. Um, so, since it is more general, we are trying to show you by solving problem using Mamdani approach. But nevertheless, similar kind of thing can be also done using Shigano method. So I will have to first tell my cell what are the inputs, okay, and what will be my output. So you see, go to the edit, and you'll have to add variable. So I have added. So in this way, add many variables you want, you can add. Okay, okay, you can add variables. Input, both input and output, right? Add variables to output. So I can. This is a 4 input, 2 output variable. But right now I am taking I am trying to solve a small problem, demonstrating you simply how to um, design an expert system. So I can just use 2 input, 1 output. Okay. So what will be my inputs? You see, input is quality of food. Okay. What could be another input? Quality of. So in tipping problem, these are very logical, right? Logically designed, quality of service, quality of food. And what will be my output? Output will be the tips, quantum of tips, right? Okay, just I have named my input output. Okay, so fuzzy logic, fuzzy inference system acts. This is my black box for the timing, and we will design this black box. Okay, but before that, what you will have to do? I will have to fuzzify the variables, the quality of food. What do I mean by quality of food? What do I mean by quality of service? Okay, so again I will have to go to edit, and then I will have to have membership. I will have to have membership functions. So these are my membership functions. You see, for input quality of food. Okay, say this is my membership function, which is um, telling me the rancid food or bad food. So it is characterizing bad food, and I can select what will be the membership function. I do not know. I can select. There are so many for designer. It has been given. I have selected one. But if you are an expert and if you have a lot of data, okay, so you can design your own membership function as well. Otherwise, they are very commonly used membership function, which are normally sufficient to make a design, and you can select from there. I could select Gaussian also, but I just selected, uh, and they have a role, of course, on the quality of the design. So, rancid food, uh, Gauss Bale type of membership function I have used. Okay, so yeah, you have to. Then this is my, say, this membership function is characterizing average food quality. Average food. You understand? Huh? So this is average food quality. Okay. It's average food quality, and I decide that it should be, say, mm, trapezoidal kind of membership function. Okay, so it's my decision. I am the designer. Okay, so it is, the cell is giving me a lot of freedom. Okay, so you see, now I am saying that this could be my excellent food. excellent food quality. Okay, and excellent food quality, and then say I am using this function. Okay, so now I have falsified my quality of food with the membership function. Now I need to also falsify the service quality. Okay, so say this is characterizing my poor service of the waiter, poor service. Okay, and say I am using this as poor service. Up to, if the value is up to this, it will be characterized as poor, uh, perfectly poor, and then not so poor, like that. You know, you have already know this membership function's meaning. Okay, and say this is average. If you do not know, of course, earlier lectures you should study. Average service. So this is average service, and say I am using this type of membership function, and say this is actually excellent service. Excellent service. Okay, and suppose I am now showing this one as characterizing excellent. Similarly, I'll have to fuzzify the output as well. Okay, so this is say first membership function is what it is characterizing. Say it characterizes miser or poor tips, right? Or means I am giving very bad tips. So this is characterizing that. So this is average. And say this is my excellent tips or generous. Excellent means I'm so happy with that food quality and service that I'm giving more than enough tips, generous tips. Okay, so generous. Okay, and say this is characterizing generous tips. So all my input output has been characterized or fuzzified. Okay, and then what we'll have to do? I'll have to now design this. That means I'll have to write the rules. These are extremely important. Okay, so now you see I'm writing the rules. If the quality of food, rancid food, okay, and quality of service, poor service, then quantum of tips, definitely poor tips, right? It is suggesting me. I can change anything, right? I can say no, I'll give generous, I'll give like that, okay. But you see, this expert system cell is helping you with the design. If the quality of food is rancid food, is bad, quality of service is poor service, then quantum of tips is poor tips. So this is my knowledge being captured in the form of if-then rule, fuzzy rule, right? So if I am satisfied, I am adding that rule, okay? Then if the quality of food is rancid, means bad, even if the service is average, still I will give poor tips, okay? So it's my design, so I have added that. If the quality of food is rancid and the quality of service is excellent, well, then I think that I should give average tips, because the poor waiter does not have much role in quality of service. So this is my sympathy for his work. His service was excellent. So suppose I have decided that I will add this rule. So similarly, if the food is average, okay, then you decide if the food is average, quality of service is poor, then quantum of tips, say poor. See, this is very important. The way you are injecting knowledge and you are injecting knowledge or your wisdom through if-then rules, fuzzy rules. So, and we are using Mamdani approach because all these membership functions are general membership function. So, I am trying to put knowledge. So if the quality of food is average, if the quality of service is also average, then okay, maybe my tips will be average. Okay, if the food quality is average, quality of service is excellent, still I think I should give average tips because food was not good. But now, if the quality of food is excellent and the quality of service is poor, still I will give some, well, I am happy with the food, average tips. So if the quality of food is excellent and the service is average, maybe generously I will give tips. So I add that rule. So you are getting my point. What is happening, right? You are actually writing if then rule. You are capturing your knowledge about the problem uh, uh, in the form of if then rule. So if the food quality is excellent and service is excellent, then of course I will give generous tips. Okay, excellent and the service is poor, maybe I will give average. Okay, then excellent, average, maybe I will give average. So like that. Okay, so explicitly I have written all the rules, and it may happen that one or two rules is actually repetitive in nature. So we'll have to make sure that redundant rules is not allowed to stay. Okay, because they will take unnecessary computation time and will give you nothing. So these are the rules explicitly I have written. Now let me see that what um, my rules are meaning. Okay. So this is the result which I have got. So this is the problem I have defined. This is the knowledge which I have injected, and this is the result which I have got. You see, the result is telling if the quality of food is average, quality of service is average, tips is also average, and in a defuzzified form, it's giving you concrete. If you now give that I have spent 2,000 rupees, what will be my tip? It will, in a defuzzified form, it will give you the suggestion. Of course, it will give you the suggestion. Decision is yours. Now, once you get the basic design, then the problem is you will have to test your design. How? On past experience, past data. If you have, for example, what is the custom of a particular restaurant, or how much tips you should give. Okay, is it a five-star restaurant or something like that? So all this past experience will play a role, and you will see that okay, what your design is telling, maybe the experience is different. So you can just redesign, taking feedback, and then you will get your result. And you can go ahead and test that whether it is performing, it's giving you a good result or not. If it is not giving you a good result, then what you will have to do? You will have to come back. Perhaps you have written some um, rules which are not appropriate. Say if the quality of food is average and the quality of service is excellent, then you have quantum optics average, right? So you can just delete that rule, okay, and some changes are there, and maybe you can replace it by quality of average and quality of services average. It should be worthy and at that result. Okay, in that way, you see, it's a design is a iterative process, right? So you will have to iterate. You will have to closely study the rules, what they are meaning. And one good thing is in fuzzy logic, fuzzy inference system rules are written in a linguistic form. So this meaningful way I can study the rules and redesign, delete, avoid redundancy, and again come back and see what is my result. Also, you can visualize the result in the form of surface, you see, like that. Huh? Uh, so you see rules, then this is my design output, and this is my output also in the form of surface. So what it is telling, this quality of service, quality of food, and quantum of tips. The suggestion which is giving in a visual form, you can see what suggestion it is giving is correct or not. And if they are not up to the mark, means they are not actually commonly practiced, is not tallying, the tips, quantum of tips is not tallying with the normal practice, then you will have to go back and redesign the rules. And even you should also redesign the membership functions. Okay, you can go and select a different kind of membership function till you are satisfied that my design is uh, quality of my design is good. And this is very tedious process, like all other design, right? Software design. Expert system design also is a tedious process. This is a basic design, and then you will have to validate your design, test your design, till the design um, is configured properly. Okay, so properly you have to calibrate all the variables. For example, you can add more variables. Okay, food, quality of service. What could be the another variable here? You can see ambience, whether it is air conditioned, whether the ambience is good, average or poor. You can add. Right? Just I am giving an example. Yeah. So, and you can more realistically design the tipping problem. So, this is this is how a fuzzy inference system can be designed for predicting something, predicting here about tips. And in real life, there could be many such problems, whose solutions are not very straightforward, and whose solutions are not cannot be which can model solution cannot be modeled as using conventional method like mathematical methods and other analytical methods. In those cases, fuzzy logic is the best tool, and fuzzy inference system is the best model of designing system. Okay. And nowadays, as we have discussed in my earlier lectures, it has enormous application. You know that you have every household, right? You have some fuzzy washing machine, fuzzy camera, fuzzy television, smart television, having fuzzy chip. So those are the applications of fuzzy inference system. Say, I will take an example of washing machine. So in the washing machine, what are the variables? Roughly, they are the dirt, level of dirt, how dirty your shirt is very dirty, is average dirty, or it is mildly dirty, right? And then, uh, depending on that, quantum of soaps you should put. Okay, so if the dirt is heavy, then of course more um, that powder, washing powder you'll have to put, and then internal parameter. I mean, how long you should beat. That also depends on you see the quantum of dirt. Then what will be the temperature of the water for uh, which you are using for washing, machine is using for washing. If it is woolen cloth, will be something. If it is cotton cloth, will be something. So all this could be you can take care as an input and write just like this a fuzzy inference system, and then redesign so that optimum design is obtained. And once it is obtained, within certain range, you can you can take those results and put it in the form of a lookup table and burn a fuzzy chip, okay, so that with those values which is written in the lookup table, the values which you have obtained from a priori or offline design of a fuzzy expert system, in the same way as I have mentioned here, uh, will make your washing machine really smart. Means it will consume optimum power, it will consume optimum um, uh, washing powder, optimum time, all kind of things. So this is another example of fuzzy washing machine perhaps you have in your household. You will see fuzzy inside. They will write. So it's a fancy thing, right? And of course, you can also design your fuzzy inference system, which can help you to tell whether you are going to get a chance in a um, foreign university for higher study. Inputs could be at the in that design. Input could be your CGPA in the undergraduate level, recommendation letter, and then test results. So if you're so all this first you will have to fuzzify if in the form of um, bad, good, average, right? If your CGPA is excellent, okay, average, poor, recommendation letter is excellent, average, poor, and test result average. So this is called fuzzification of the variables, okay, and then you will have to write the rules, okay, and you will get some answer, and in a and after defuzzification you will get a complete answer. Here in this case could be possibility of getting chance in a particular university, and then you design, redesign, verify it with your past records of many friends who have got a chance in that university, and then reconfigure the design and then use it for prediction. And that may help you in wasting your time, effort, money in applying in those universities, for example, where the possibility of getting admission is poor. Or on the other hand, if the possibility of getting your admission is excellent, you should go ahead and apply it to those universities. So all kind of examples are possible, all kind of problem you can solve, uh, which otherwise is difficult to solve using your fuzzy inference system. So I hope you enjoyed this video. It's fun. We took a fun example and I demonstrated you all the steps and all these complications which you may encounter, okay, in designing a fuzzy inference system. See, in the expert system cell, you have seen there are customized, they have made available many um, membership functions. Okay, you can design your own membership function. Then, of course, with data, you have to design your own membership function for fuzzification of a particular variable, and then you will have to tag to the cell. Okay, that itself will be considerable amount of work. But if you want customized, very good design, you'll have to put that effort. Okay, so there is no freelance, right? So you put your effort, you um, collect data, you design, redesign, you can make it more sophisticated design. Okay, but this is the basic idea of how expert system can be designed using fuzzy logic. With this, I hope you have understood. If you have any query, you can write in the comment box, or you can come to the discussion forum. Till then, you see, I am now living, I am wearing a mask. So follow it very carefully. Have a nice day. Be safe. Goodbye.